So question 16. A smooth sphere of mass 3m and velocity 4u impinges directly on a smooth sphere of mass 5 meters and velocity 2u, moving in the same direction. The coefficient of restitution is e. For what value of e will the velocity of p be halved by impact? Okay, so what we're going to do is set up our before and after system. So there's one of them there, and then the second one would be just this here. So our two spheres colliding into each other before and after. Okay, so going to start off with that's 3m, the other one's 5m, that's 3m, the other one's 5m. Then put in our values, we're going 4u. This one's going 2u in the same direction. Okay, and then after impact we have phi1 and phi2. We have a PCM, principle of conservation of momentum, m1u1 plus m2u2 equals m1 v1 plus m2 v2. Start off with the principle of conservation of momentum. We're going to have 3m times 4u plus 5m times 2u equals 3m v1 plus 5m v2. 3v1 plus 5v2, 12 plus 10, going to give me a 22u. Okay. So, yeah. Are we happy enough with that one? Now, NEL, Newton's experimental law, is done as phi1 minus phi2 over u1 minus u2 equals minus e. So what we're going to get here is phi1 minus phi2 stays the same, and then u1 minus u2 is going to be 4u minus 2u equals minus e. phi1 minus phi2 ends up to be minus 2ue. So we have our two simultaneous equations now. Can I get rid of that straight away? Okay, so our two simultaneous equations are a here and b down here. Okay, so I'm going to multiply the bottom equation b by 5. So we're going to get 5v1 plus 5v2 equals minus 10ue. If I reread the question, it wants the velocity of p to be halved. So I really want to find out phi1 before I find out phi2. This is just the correct time management. Yeah?
Is there a minus in between the v's on the green one?
On the green one?
Instead of the...
There is, yeah. Yeah, you're right. Because I multiplied that one by 5. Yeah, thank you. And the top equation is 3v1 plus 5v2 ends up to be 22u. Okay, now you're going to add straight down, and when we add straight down we're going to get 8v1 equals 22u minus 10ue. Factorize out 2u into 11 minus 5e equals 8v1. Divide by your 8. v1 equals u into 11 minus 5e all over 4. We want our speed to be halved. So our speed used to be 4u. We now want v1 to be equal to 2u because it says it wants the speed to be halved. So therefore this entire equation has to equal 2u. So u into 11 minus 5e all over 4 has to be equal to 2u. The u's will cancel. 11 minus 5e has to be equal to 8. 5e therefore equals 11 minus 8 is 3. E will equal 3 over 5. Or 0.6. Okay? So we know that much is correct anyway. So guys, what we did there was we multiplied, I'm just going to double check this because I have a feeling I made a mistake there anyway. So I'll go back from scratch. We multiply, we're going to find V2 now, so we multiply equation V, multiply equation B by 3, minus 3 that is, you get minus 3V1 plus 3V2 equals 6UE. Multiply the top equation by, don't multiply the top equation at all, so you have 3V1 plus 5V2 equals 20U. Take them away and we get 8V2 equals 22U plus 6UE. Bring down the 8, factorise out 2, and we end up with 11U plus, anybody, 3E. Okay, that's right. Now, oh yeah, I got it. V2, I got it. Okay. Divide it, and you get U equals. Oh yes. Yeah. So we get U into 11 plus 3E all over 4. Sorry guys, it says at least. See the word at least 2.75. Okay, we gotta test both ranges. We gotta test E equals 0 and E equals 1. See which one's bigger. Okay, so if I put down E equals 0, what do I get? I get 11U over 4, which is my 2.75 U. If I put in E equals 1, I get 14 over 4U, which is going to be 3.5. So long story short, your minimum value is when E equals 0. Your minimum value will get you 2.75. However, your maximum value will get you 3.5. Is that right? A small sphere moves on horizontal floor with speed 2u. It strikes an identical line, the sphere line at rest on the floor, a distance 1 meter from a vertical wall. Vertical wall, okay. So I think what we're looking at here is this one, and then just random wall over the way, 1 meter away. Okay. So then what we're going to do, so we have our before and after picture here. Okay. So identical spheres, what would that mean? Sorry, same mass, M and M. One of them's going 2u. What's the other one doing? Line at rest. Then after the collision takes place, what happens then? We have Phi1 and Phi2. Once again guys, prove that the speeds of the spheres after the first collision are these two values here. So you want to find out what your Phi1 and Phi2 are down here. Okay, so let's do PCM. M1U1 plus M2U2 equals M1V1 plus M2V2. So the PCM formula will be 2M times U plus M times 0 equals MV1 plus MV2. V1 plus V2 equals 2U. Next thing you're going to go to is NEL, which is V1 minus V2 over U1 minus U2 equals minus E. Now, once you have that, what we're going to have next is V1 minus V2. Does it tell us what E is? No, it doesn't. And then on the bottom we're going to have 2U minus 0. So that's going to be V1 minus V2 equals minus 2UE. 2V1 ends up to be 2U minus 2UE. Divide by the 2's. V1 equals U into 1 minus E. So that's V1 right there. To get V2, just going to do a modification on this. I'm going to turn that to a minus, that to a plus, that to a plus. I'm now going to get 2V2 ends up to be 2U plus 2UE. Once again, the 2's are going to go away, and phi2 ends up to be 1 plus E. Where's my U gone? Yeah, the U is going to be factorized now. U into 1 plus E. Double check, and you've got both of them right. When the second sphere hits the wall, the spheres are a distance 2E over 1 plus E apart. The next collision takes place at a distance 2E squared 1 plus E squared from the wall. Alright, so proof that the second sphere hits the wall when the spheres are a distance 2E over 1 plus E apart. Okay. It's an interesting one. So what it's going to is distance, okay? So what we're going to have to do is find time. So I'm just going to store my two values here, and then just go back to my diagram. That's old information, so I don't need any of that anymore. Just need this part here and this part here. Okay, so get these two parts here. There you go. Okay, so what happens is it's currently going with a speed of u times 1 plus E towards the wall. It has exactly 1 meter to cover. Okay, so we're going to have to find the time it takes for that to happen. Okay, so time equals distance over speed. Therefore, if time equals distance over speed, what it's going to be there is it's going to be 1 meter divided by u over 1 plus E. And now all of a sudden, once that happens, you're going to be actually at the wall. No, it's all grouped. So you're going to be at the wall with the second particle, which is here, and then the other particle is going to be coming towards you as that's happening. So they're both moving to the right, and when this one reaches the wall, the other one is still coming towards it, and that one's only starting to rebound now. Okay, so how much distance did you cover in that time? Okay, so the distance travelled by the other one is distance multiplied by time. Okay, so the second particle is at the wall. How far did the first particle travel when that happened? So distance equals speed multiplied by time. Speed of the first particle is u into 1 minus E, and we're going to multiply that by our time, which is 1 over u into 1 plus E, and that ends up to be 1 minus E over 1 plus E. So that's how far we travelled. Okay, we're still looking for this answer here though. Okay, so the distance apart equals 1 minus 1 plus E. Okay, yeah, got it. Alright, so just going to draw as a new diagram. Okay, so your new diagram when they collided with each other, they're both just no gap between the two of them. Okay, then this one here travels 1 meter to the wall. Okay, so it travelled 1 meter to the wall from where it was and now where it is. Between its old centre and its between its centre, it travelled 1 meter. Okay, in that time, the second particle also travelled a distance. Okay, and what this distance is you're going to have to take it away from 1, because it travelled 1 meter, but the other one was travelling alongside it. So we got to take away 1 minus the distance. that the second particle travels. So 1 minus e all over 1 plus e. We're going to get them in the same denominator. So the number 1 is going to change into 1 plus e over 1 plus e. And then you're going to take them away from each other. The 1's will cancel and we're going to get 2e over 1 plus e. Everybody happy enough with that? That's the distance between them, just as the second one hits the wall. Okay? So, that's that one done. The next collision takes place at a distance 2e squared, 1 plus e squared from the wall. Now let me explain what that means. What's the e value? Oh yes. So, as this one hits the wall, what happens next is this one is still travelling forward at a velocity u into 1 minus e. The second one is now travelling backwards. Now how do I find its new velocity? Do you remember when a particle hits a stationary wall, phi equals minus e times u? It would have been from exercise 1. Your final velocity, excuse me, your final velocity your final velocity is minus e times your initial velocity as you're hitting the wall. Your initial velocity as you're hitting the wall is your u into 1 plus e. Yeah. Now, velocity therefore is equal to, we'll just multiply this out, that's going to be u plus ue, multiplied by minus e, you're going to get minus eu minus e squared u. Is that right? So that's your velocity, that's your rebound velocity, so it's going to be, I suppose we can still take out u there. You can take out minus u, and we can have minus u into, just take out u to make it look like the second one there. So, 1 second. Okay, so take out minus u, and we're left with e plus e squared. Okay, so into e plus e squared. Now you have two objects coming towards each other. Okay, so these two objects are coming towards each other, and what was their initial distance that they were separated? So they're both coming towards each other. Particle 1, particle 2, and they're both going, one's going this way, the other one's going that way. What was their initial displacement from each other, just as it rebounds off the wall? Any idea? 2e over 1 plus e is their initial displacement apart, and we know what speed they're coming at towards each other. Okay, that's grand. Yeah. Now, what we can do here is, anybody remember relative velocity? I'm going to give you an example now of what we can do here to make this really easy on ourselves. If you're ever not sure about how to go about doing a question, do a simplified version of the question. So an example would be, if I had, I'll just do it here. Imagine I changed this to 10. The distance they're apart is 10 meters, and this one is going towards the wall at 2. This one's going back away from the wall at 3. What can I do to find the time taken for that to happen? And we know what I can do to find the time taken. I can hold one of them stationary. I can hold the second one stationary, and then when I hold that one stationary, that's going 0. And what's the second particle going towards it at? 5. And then you can say 5 into 10 goes 2 times. You can find the time taken for them to collide really easily by using relative velocity. So we're going to do the same trick here. Okay? So, what we're going to do is we're going to, we know the distance is 2e over 1 plus e. We know that this one here is going u into 1 minus e. We know the second one's going minus u into e squared plus, e plus e squared. So what we're going to do is I'm going to use relative velocity here to find the answer. So I'm going to say time equals distance over relative speed. So to use the relative speed, what we're going to do is we're going to have to change the sign of the second one. Remember, if you're going 3 in this direction, or sorry, 2 in this direction, but you're going a negative 3 towards the 2, it's going to be 2 minus 3 to give us the 5. So I'm therefore going to have to do u into 1 minus e. Then it's going to be minus, which will turn it into a, plus u into e plus e squared. I'm just going to multiply it out this time. So it's going to get u minus ue plus ue plus ue squared. And exactly what I was looking for happens. I made to get rid of 2 of them here. Simplify it. And then I'm going to get u into 1 plus e squared. That's the time. Okay? So I have the time taken. Now how do I find the distance at which that occurs at? And we know how do I find the distance? So 1 second. Oh wait a second. Ugh. Sorry, I'm stupid. I haven't done the time yet. Also I did there was the relative speed, wasn't it? That's basically phi1 minus phi2. That's to get technically that's getting the 5. Okay? So I actually haven't divided it in yet. So time equals distance over speed, which is going to be what, guys? Time equals distance is 2e all over 1 plus e, and that's going to be all over u into 1 plus e squared. Okay, now I have to turn it into 2e squared all over, oh, the e squared's in there. Okay, have to turn it into that there. Okay. So that's the time taken. Everybody happy with the time taken? There's the time taken. Now, the whole point of the question was find the distance. So, which sphere should I take? If I have the time, which sphere should I take to get the distance away from the wall? I should take the sphere that was at the wall. So I'm taking the sphere that was at the wall, and it is going at a speed of, I don't have to worry about the sign, I just have to worry about the magnitude. An example being, if I had a time of 4 and this is going minus 5 to the left, we know the distance it's going to travel is minus 20. But do I need to worry about the 5, the minus in front of the 5? I can still just say it's 20 meters away from the wall. So using that logic, I'm going to go up to my V2, which was this one here, right? And with that V2, I'm just going to ignore the minus sign and just treat it as u into e plus e squared. So u bracket e plus e squared. So I now have to multiply, to find the distance, I have to multiply speed by time. So distance equals speed multiplied by time. So what we're going to get is u into e plus e squared. And the time is a complicated one altogether. It's going to be 2e over 1 plus e all over u into 1 plus e squared. Keep an eye on what you're meant to turn that into. You're meant to turn it into 2e squared all over 1 plus e squared. So that's what we have in mind when we're doing this. So let's see how we're going to go about doing this. Now, I'm going to I'm going to factorize this, and I'm going to turn that into ue into 1 plus e. The 1 plus e's will now cancel. I'm going to multiply the ue by 2e, and I'm going to get 2u squared. All being divided by u into 1 plus e squared. The u's will cancel, and I'll get 2e squared all over 1 plus e squared. And that's your answer done.